everyone, in order to maintain peace and security, humanitarian assistance, with increasing population in the entire world, sustainable development in agriculture will be very key essential. I'm Evans Odinga Ogingo from Egerton University, Kenya. Currently I'm doing my research on breeding of heat-tolerant livestock under Kenya Climate Smart Agricultural Project. I'll be taking you through my research proposal on evaluation of environmental sensitivity of genetic merits for growth and fertility traits for zebu cattle in Kenya. Beef production is very key essential in economic development of Kenya, where it provides around 14% of agricultural GDP. In ASAL, it provides value and employment. These ASAL areas are associated with constraints of climate change, which requires improved animal adaptation. Most farmers in these areas have utilized various breeds such as improved Boran, Zebu, and their crosses with the exotic breeds, some of which are not adapted in these areas. Farmers in these areas have decided for improvements in fertility traits in order to reduce the cost of production despite the changing climatic conditions. Constraints of climate change such as increasing environmental temperatures, fluctuation in weather conditions, frequent droughts and floods, increased incidences of pest and disease occurrence have affected growth and fertility through reduced quantity and quality of forage. To add on this, heat stress have also affected appetite of the animal, feeding, reduced growth, and also affected reproduction rates in cattle. Variation in beef cattle in terms of coat color, breed, age, temperature humidity index influence physiological and behavioral response of beef cattle to changing climatic conditions. Water seeking, shade seeking, adjustment in respiration rate, body temperature, heart rate are very essential in promoting survival and welfare of animals in specific environments. Most genetic improvement programs in Kenya have focused on improvement of growth through selection. Where failure to focus on adaptation traits in conjunction with changing climatic conditions, there's a possibility of genotype by environment interaction. Zebu cattle in Kenya have different coat color and coat type. Therefore, their response to climate change will be varied due to season, environment, breed, and even age. Studies on genotype by environment interaction have reported ranking of ready cattle genotypes for milkid. The production environment also changes across the growth curve. Therefore, it is expected that vertical genotype by environment interactions is going to occur for growth and fertility traits as climate change continues to alter environmental conditions. Options to deal with G by E include breeding for robustness and canalized breeds. My statement of the problem of the study is that climate change have led to increased environmental conditions, especially increasing temperatures above thermal comfort zone, resulting to emergence of disease and pests in the population. The response of beef cattle to climate change in terms of physiological and behavioral response within Kenyan environments have not been quantified. Genotype by environment interaction for beef growth and fertility traits between environment and over time have not been also quantified. My general objective for the study is that to increase contribution of beef cattle to economic growth in Kenya through improved adaptation of beef cattle to changing climatic conditions. My specific objectives are to evaluate the effect of zebu cattle coat color and coat type on animal behavior and physiological response in Kenya. 2, to evaluate the extent of heterogeneity of genetic parameters for growth and fertility traits based on coat color. And the third will be to describe genotype by environment interaction for growth and fertility traits of zebu cattle based on coat color. My justification of the study will be that knowledge on physiological and behavioral response of beef cattle to effects of climate change will enable development of mitigation measures to counter the negative effects of climate change. Also, by estimation of variation in fertility and growth traits due to coat color may help to link coat color with the resilience depending on level of variance components. Also, analyzing the magnitude of genotype by environment interaction across beef cattle production environmental gradients will provide a basis of identifying genotypes which are resilient to the effects of climate change. The study will also provide environmental parameters that can be used for the study of the effects of climate change in ASAL's parts of the world. Thank you.